Hey guys, Victoria here and welcome back to my channel. So in today's video, we'll be going over the formulas in chapter 2, and this will be one of the two videos that I'll be putting out. So because chapter 2 is a long chapter and there's a lot of formulas, I'll be splitting this video into two parts. So once I upload the second part, I'll leave the link in the description box below so that you can access the second part. So anyway, from 2.1, the first formula that we have is the formula for speed, which is equals to distance over time. And the unit for speed is meter per second. Because the unit for distance is meter and the unit for time is second. And then the next thing we have is velocity, which is equals to displacement over time. So displacement, the unit for displacement is meter and the unit for time is second. So the unit for velocity is meter per second. So I always say that if you can memorize the formula, then you can easily derive the definition from the formula. So for example, the formula for velocity is displacement over time. Then the definition for velocity will be the rate of change of displacement with time. And another thing that I want to mention here is that speed and velocity are basically the same thing, except for the fact that speed is a scalar quantity, which means that it has magnitude only, and velocity on the other hand is a vector quantity, so it has magnitude and direction. So this is important because sometimes in paper 2 they might ask you the difference between scalar and vector quantity, or it's also important in the sense that sometimes when you write your answers for velocity, you have to specify the direction, or you have to write whether it's positive or negative. But if it's speed, then no direction is needed. Number 3, we have acceleration. Acceleration is velocity divided by time. Unit for velocity is meter per second and time is second. So unit for acceleration will be meter per second square, and the official formula for acceleration is actually A equals to V minus U over T, which is a very important formula. And V stands for the final velocity, and U is the initial velocity. So another thing that I want to mention is, if in the question it's mentioned that the object stops after a while, if the object stops moving, V will be equals to 0. Final velocity will be equals to 0. And if the object starts moving from stationary, it is U equals to 0. So from beginning it starts moving. From a stationary state. So these are keywords that you can look out for. Next, we can look at the ticker tape. So an important formula which involves ticker tape is T equals to 1 over F. So T stands for time and F stands for frequency. So usually the frequency will be given, and usually it will be 50 Hertz. So I'm also going to be talking about how you can calculate the acceleration based on the ticker tape. So let's say you're asked to calculate the acceleration of the ticker tape, and all you're given is the frequency. So from the frequency, you are supposed to find the time for one tick first. So time for one tick will be equals to T equals to 1 over F, which is equals to 1 over 50, because the frequency is 50 Hertz. So your one tick will be 0.02 seconds. That is the time for one tick, but you have to find the time for all these ticks of this ticker tape. So a lot of people get confused about how to calculate this. Basically, it's from the midpoint to midpoint. So what I mean by this is one midpoint, this is another midpoint, and these are all midpoints. So you go from one midpoint to another, so it's 1, 2, 3, 4, 5, 6. So the total time here will be equals to 0.02 multiplied by 6, which is 0.12 second is the time for the entire ticker tape. So remember to go from midpoint to midpoint. Let's say you have 4 points here. This is the midpoint, and you go 1, 2. So you have to multiply by 2. So anyway, to find the acceleration, start by writing the formula for acceleration first, which is a equals to v minus u over t. So we can start by finding the initial velocity, which is u, and u in this case is the beginning here. And sorry, I forgot to label this, but the distance between the first one is 2 cm, and the distance for the last one is 4 centimeter. So u will be equals to 2 centimeter divided by the distance, the time taken for one tick, which we have already found from here, 0.02. And so the initial velocity will be 100 cm per second, and the final velocity is 4 cm as seen here. So 4 divided by 0.02, and you'll get 200 cm per second. So now you can sub all this into your formula for acceleration, which is a equals to v minus u over t. So a equals to v, which is 200, minus u 100 over t, which is 0.12. So your acceleration will be 833.33 cm s negative 2, or usually we'll convert this to meter. So move two sides, 2 points backwards, and you will be left with 8.33 ms negative 2. So that will be your answer for ticker tape acceleration. And next we'll look at some of the equations of linear motion that are very important and should be memorized. So the first one, v equals to u plus at, s equals to 1 over 2 u plus vt, s equals to ut plus 1 over 2 at square, and the final one is v square equals to u square plus 2as. So you have to know what all these variables stand for. S stands for displacement, u is initial velocity, v is final velocity, a stands for uniform acceleration, and t stands for time interval. So it's very important that you memorize all these 4 equations and apply accordingly. So usually what I would recommend doing is, after reading the question, list down all the variables that you have first. For example, all the variables that you're given, if final velocity is 50 ms negative 1, then you can list that down, or whatever that you're given, you can list that down first and then just match accordingly to the formulas here. And I will usually list down all the formulas just to identify which one I can actually use. And next, we are going to be looking at the displacement time graph. So the displacement time graph will look something like this, and of course on the x-axis is the time, and y-axis is the displacement. And let's say your graph looks something like this. So you have to know what all these paths in your graph actually mean. And you should also know how to calculate velocity from this graph. So what you must remember is that the gradient of the displacement time graph represents velocity. So for example, if you want to find the velocity in the first part of the graph, then you will have to find its gradient, which means take your y divided by x. And that will be your velocity. So remember that for displacement time graph, gradient represents the velocity. And there are different meanings for different section of the graph as well. So for example, for this upward slope in the first part, it basically means that the object is moving at a constant speed forward. So same with this third part here, it's also moving with constant speed forward. And then when there is a horizontal line like this, and this, and this basically means that the object is stationary. It's not moving at all. So the three parts here means that the object is stationary. And finally, we have the downward slope here. The downward slope means that the object is moving with a constant speed backwards. So that's for displacement time graph. And next we'll look at the velocity time graph, because they mean different things, so you must be very careful and differentiate between velocity time graph and also displacement time graph. So let's draw a velocity time graph first. Looks something like this, and of course on the x-axis we have time, and y-axis there's velocity. So an important thing that you have to remember here is that area under the graph for velocity time graph is equals to the distance traveled. But on the other hand, area under the graph for displacement time graph means nothing, okay? But for velocity time graph, the area means distance. So you can use this to find distance. If you find the three areas, and usually we'll find the area of two triangles plus one square based on this condition. So we divide this into three parts and we'll find the area here, adding here, and the final part. So this is how we'll find the area under the graph, or in other words, the distance traveled. And gradient, on the other hand, represents acceleration. So again, this is different from displacement time graph because the gradient here represents velocity, but in velocity time graph, the gradient represents acceleration. And let's talk about what the different parts of this graph means. The first one is the upward slope, and the upward slope will mean positive acceleration. So positive acceleration means that the speed of the object or the velocity of the object is constantly increasing. So that means it's a positive acceleration. And when the line is horizontal like this, it means that there is zero acceleration. But the object is actually moving at a constant velocity. So very important here, because if you look at the displacement time graph, when there's a horizontal line, the object does not move at all. But for velocity time graph, if there's a horizontal line, the object is moving at constant velocity. So sometimes they like to trap you like this in questions. So just be careful to differentiate between velocity time graph and displacement time graph. And finally, the last part of the graph, the downward slope, represents negative acceleration, or in other words, deceleration, which means that the velocity is decreasing. So next, Number 8, we have the formula for momentum, which is mass times velocity. So P stands for momentum, M stands for mass, and V stands for velocity. And unit for momentum is kg ms negative 1. And the definition for momentum is very important as well. It's basically the product of mass and velocity, and that's a commonly asked question for subjective. And number 9, elastic collision. So very important to know what it means by elastic and inelastic collision. In elastic collision basically means that after colliding, the object moves separately as two different things. So for elastic collision, the formula is m1u1 plus m2u2, and this is equal to m1v1 plus m2v2. So m1 is the mass for the first object, m2 is the mass for the second object, and u represents the initial velocity, and v represents the final velocity. And then we have inelastic collision. In inelastic collision, the object will collide and they will move together as one. So the formula is m1u1 plus m2u2 is equal to m1 plus m2v. So if you notice here, in inelastic collision, there's only one velocity. It means that both objects move as one, and so they only have a single velocity because they share the same velocity. And then next we have explosion. The formula for explosion is 0 equals to m1 v1 plus m2 v2. And you can move one of these to the other side, which makes it m1 v1 equals to negative m2 v2. And this is usually seen for rifle or for guns. So based on the situation, you will have to judge whether it's an elastic or inelastic collision, and then apply the formulas accordingly. So in all three conditions, the total momentum are actually conserved. Alright, and then we'll look at number 12. Number 12, F equals to KMA. So K here, F will be equals to force. K is a constant which has no unit. M is equal to mass, and A is equal to acceleration. So the unit of force, very important, is Newton, or we simply write as the capital letter N, or the alternative unit is, because the unit for mass is kg and the unit for acceleration is ms negative 2. So the unit for force is also kg ms negative 2. So usually if it's subjective question, of course I'll just write Newton as the unit for force, but sometimes they like to ask you the unit for force in objective question or in paper 1 in hopes that you won't remember, but just remember that it's kg ms negative 2. That's the unit for force as well. And then 13 is the formula for impulsive force, which is mv minus mu over t. So F stands for force, M stands for mass, V stands for final velocity, U stands for initial velocity, and T stands for time. So the unit for force is also Newton, or kgms -2. So it does not matter which type of force it is. The unit is always Newton. And then finally, number 14, net force is equal to total force minus frictional force. So be careful, sometimes in the questions they will mention the frictional force, so you have to actually subtract that frictional force from the total force. And it won't be as simple as just finding the net force. Sometimes it will be a question which involves the equation F equals to ma, and they will give you a frictional force as well. So you have to take F minus frictional force and equate it to ma. So that's how you will find the net force. So this is the first part of the video for chapter 2, and I will leave the link in the description